Let's take a look at section 3.2. 3.2, proving figures are congruent using rigid motions. The learning target here is I can determine whether two figures are congruent using rigid motions. Let's look at the definition of congruency first. So two figures or objects are congruent if they have the same shape and size, or if one has the same shape and size as the mirror image of the other. So when we're thinking about rigid motions, right? Rigid motions preserve shape and size. Okay, so in order to show that the two figures are congruent, you just have to show that there is a rigid motion that maps one to the other, and that way, therefore, they would be they are congruent. Okay, let's look at the first example. Use a definition of congruence to decide whether the two figures are congruent, and explain your answer. This first example here, we have these two figures, C, D, E, F, and then L, M, J, K. And we're trying to show that they are congruent. So if we can show that there is a transformation, like a rigid motion, I mean, that maps one of the images to the other, then they are congruent. It looks like C, D, E, F, and M, L, J, K, they look the same shape and size. But now we have to show, okay, if we were to flip one image on top of the other. So if we flip the image across the y-axis, notice that point E is going to fall exactly where L is, right? 1 unit away from the y-axis, and then L is 1 unit from the y-axis. If we notice point F is 2 units to the y-axis, M is also 2 units, so F and M, they could be mapped to one another. Let's see, C looks like it's half the way here from between 7 and 8 going up on the y-axis, and it's 1, 2, 3 units to the y-axis, 1, 2, 3 units to the y-axis. So C and J are the same unit on opposite directions of the y-axis. So it looks like you can map C, D, E, F onto J, K, L, M by reflecting the quadrilateral over the y-axis, okay? So because this reflection is a rigid motion that maps CDEF to JKLM, so the two figures are congruent, okay? And then the coordinate notation for the reflection is x comma y maps to negative x comma y, which is the rule for reflecting across the y-axis. Okay, for the next one, let's take a look at these two triangles. Um, so they look the same shape, right? They appear to be the same, but we have to kind of prove it, right? But if we think about this side XZ, right? XZ, I could say that CA would be the corresponding side, right, to XZ. So it looks like we could maybe rotate. Let's take a look at here. So if we kind of like, we could go like this, rotate it, right? And then that triangle would fall right on top of the other, okay? So, but in this case, we're going from triangle ABC to triangle XYZ. So we're kind of like rotating it on the other direction, right? Which is counterclockwise, okay? And that's a 90-degree rotation, okay? And what you can do is you can check your points, right? And you can check your points and see if the rule works, okay? In this case, we would find that it would work, like point C would rotate to point Z, A would rotate to X, and B would rotate to Y. Okay, so you can map triangle ABC to triangle XYZ by a counterclockwise rotation of 90 degrees around the origin. Okay, this is a rigid motion, so the two figures are congruent. Okay, the coordinate notation for the rotation is X comma Y maps to negative Y comma X. Okay. Now, on your template, you should be trying now the problems that come next. There are two problems for you to do here. Again, you're doing the same thing. You're showing that there is a rigid motion that maps one picture to the other, and then therefore the two pictures are congruent. Let's take a look at example 2. Now we're given that two figures are congruent, and we want to find a rigid motion or a combination, a sequence of rigid motions that maps one onto the other. So let's take a look at triangle ABC, and let's try to map it onto triangle PQR. If I were to do a rotation, okay, if I were to do a 180-degree rotation, okay, that would put my triangle on that quadrant, okay, so that part works. So let's see here, point C, okay, point C is right here at -1, -1. If I rotated this point, it would end up at 1, 1 if I rotated 180 degrees, okay? Notice that because it's the same distance from the origin, right? C is this diagonal from the origin, and this point is also that diagonal 1 unit from the origin. Now, what we would have to do is, in order to get point C onto R, right, we would have to slide it, okay? So that we would have to slide it 1 unit to the right. And look, notice that our scale here is by 2s, so this would be 1 unit, okay? So this is 3 right here. So that's 1 unit right there, okay? So what we're doing here is we're rotating, okay? It's a rotation of 180 degrees around the origin. This is clockwise, okay? And then that's our rule for it. And then we translate, okay? We translate 1 unit to the right, okay? And we don't move the y at all. So we just slide it over to the right 1 unit. So that's why the translation is x plus 1 comma y, okay? Now let's look at the next one. The next one we have these quadrilaterals, okay? We're told that the quadrilaterals are congruent, okay? Notice that they're on opposite sides of the y-axis, so I could try to flip it, right? So if I flipped triangle ABCD across the y-axis, it would end up on this side, okay? And notice that if I flipped it, it would be the mirror image of that one, okay? And then all I have to do after that is I have to slide it, okay? I have to slide it down so that it falls right on top of this one, okay? And so the reflection rule here is negative x comma y, which is the reflection across the y-axis. And then the translation is x plus 2 comma y minus 10, okay? So after I flip it, okay, after I flip it, I have to translate it 2 units to the right and then down 10 units. You have a couple of problems to work on your turn. So let me show you what that looks like. You have that with you. Right here, you have 2 problems, okay, for you to work on. And then the homework is listed down there. So come to class and we'll talk about your turn if you have any questions.